Hi, folks. If I can get your attention, I'm Nick McEwen, and I don't know about you, but every couple of weeks, an email shows up in my inbox with a newsletter from Bruce and Larry with some thoughts about system design. Many of you probably get that too. Raise your hand if you get that newsletter too. I mean, if you don't subscribe to it, you really should, and definitely after today. So when I was asking people about Bruce over the last few days, ready for this, several people said the same thing. The newsletter is always an interesting read. It contains ideas and insights about systems, architecture, usually has a story about the historical context to tell us where it came from, and it always has opinions. Opinions that we can agree with or disagree with. It's up to us, it doesn't matter. The key thing is they always explain how they came to those opinions and why they hold them so that we can reach our own conclusion. And it's always been one of the things that I've admired most about Bruce. You can always have a good debate with him about system architecture, system thinking, systems approach. And I always come away thinking that I've learned something new. His devotion to writing and sharing that thinking through books that Bruce and Larry write, and then they make them available for free online. It's helped educate a whole generation of system designers, including, I'm sure, many of you in the room. So Bruce got started in this whole systems design work back in 1988, that was 37 years ago, by designing the first gigabit NIC. Larry tells me it actually only ran at 622 megabits per second, but they were rounding up in those days. But after that, he moved to Cisco, where he developed MPLS with Yakov Rector. So raise your hand if you know what MPLS is. Okay, now a moment of honesty. Keep your hand raised if you really know what MPLS is. And if you could teach a class about how it works and where it came from. How many people? See, the number got a little bit, I'll come back to that in a moment. So Bruce and Yakov dreamed up something called tag switching in the late 1990s, and later it was called MPLS. And to a large extent, as a research community, we ignored it. We didn't put it in our textbooks, we didn't teach it in our classes, or accept SIGCOMM papers about it. We basically ignored it. Yet MPLS was pretty much how the backbone of the internet was built out. So why did we ignore it? I think it's because it was simple and pragmatic. And that says more about us than it says about MPLS. The hardware was so much simpler than full IP routing. It just had to switch labels, that's all it had to do. And the control plane was lifted up and out of the box. Anybody could put those labels into the tables. So it was an example of a system that was simple and elegant, so much so that as an academic community, we didn't really know what to do with it. There was no complexity to show off and brag about. There were no fancy algorithms to prove. It was just plain, simple, pragmatic system design. And it mattered to Bruce that MPLS was a simpler, faster, and more elegant way to build a backbone. And to me, this is classic Bruce. I got to see it up close when Bruce joined Nicira in 2010, pragmatic to the core, always thinking deeply about how systems are designed and how you articulate that design. And we're lucky that he's dedicated the past 10 years with Larry to sharing his thinking with all of us. But you may not know this, not only does he think quickly on his feet, he runs damn fast, too, on those same feet. Oh, my goodness. He ran a marathon in 2 hours and 47 minutes. If you know anything about marathons, that's bloody fast. Certainly something I couldn't even contemplate. Several people here have told me that they were coached by Bruce. He actually coached them to do their first marathon, including Nick Feamster at Chicago. And he described Bruce as an amazing coach, always egging him on, and always kind. So his kindness and generosity, which sometimes doesn't come through in that opinionated writing, it goes way beyond that mentoring and coaching, the runners and researchers. So for example, he donated his SIGCOMM award money today to Girls Who Code. Despite all these accomplished, Bruce never actually takes himself too seriously. It's one of the things I admire about him. I first heard this quote from him that I think sums it up. This was a quote from Bruce. I think it's from somebody else, but it's one that he uses. "You will become way less concerned with what other people think of you when you realize how seldom they do." I think that's a life lesson. I think that's great. Bruce, as you probably know, has a great sense of humor, and he frequently takes jabs at himself. And actually, this is how I first got to know Bruce, and I can tell you it's the most repeated story of people I asked about Bruce, including just now from Ellen. So at the 2003 Karlsruhe, Germany SIGCOMM, there was an outrageous opinion session. And I think some of you were there. It was, I think, the most memorable outrageous opinions talk I ever saw. And for good reason. He cataloged the challenges of getting the research and teaching community to take MPLS seriously, even though it was being used to build the internet around us. So throughout the talk, he kept repeating the line, "I'm not bitter." And that line, to me, has become part of the SIGCOMM vernacular ever since, a bit like the parrot sketch in Monty Python. So I don't know if he's going to offer any of those outrageous opinions today, but I'm sure he's going to challenge our thinking on system design, and I'm looking forward to hearing it. So without further ado, it's my great pleasure to award this year's winner of the SIGCOMM Lifetime Achievement Award to Bruce Davie for fundamental contributions in networking systems through the design, standardization, and commercialization of network protocols and systems, and for continual education of the community on past, present, and emerging network trends and technologies. Bruce, where are you? Oh, you're there.
Amazing. You just gave my entire talk.
Oh, there you go. Yeah. There's a picture being taken there now. Oh, great. I'll leave it to you.
Okay, fantastic. We need some help now. Okay. Well, Nick, that was fantastic. Thank you very much, and thank you all for showing up to welcome me to receive this award. There's a pretty good chance I'm going to cry at some point today. I'll try to delay that as long as possible. So without further ado, I should also say, one of the jobs that I had when I was at VMware was the CTO for Asia Pacific. CTO in some circles means Chief Talking Officer. Unfortunately, many years of doing that has taken its toll on my voice. There is a 50-50 chance that I will have to take a little break before the end of the hour. And I've got a lot of beverages up here to get me going, but just if you notice my voice is a bit strained, all I can say is it was a lot worse last night. So fingers crossed we'll get through this. Well, thanks again, and without further ado, let's get moving. If you've seen the abstract, I call this talk Water Under the Bridges. That's a photo of the Golden Gate Bridge that I took during a long bike ride when I used to live in San Francisco. And I'll be saying a lot more about bridges. And I'll just also point out some social media handles there. There's my personal one and the one that I created for Systems Approach. They're on Mastodon, which I'll be saying more about as well. Well, it's very traditional in these talks to thank everybody. Not having been an academic in any serious way, I don't have a whole list of students to thank, but I have a lot of people to thank. So I'm just going to thank them from now until the end of the hour, at which point the music will start playing and they'll drag me off like at the Academy Awards. But I really want to thank this community. I came to my first SIGCOMM conference in 1990, and I looked at the t-shirt yesterday, and I think I've been to about 27 SIGCOMMs since 1990. So if nothing else, I've been persistent in showing up at this event, and thanks for the reward for persistence. And there's just a lot of people here I want to thank, and I'll thank some of them by name, but I'll start with this guy. You've already heard from Nick how Larry and I work together. He has been a friend, a colleague, a mentor, and these days my co-owner of a very small, not profitable company called Systems Approach. And he's just made a huge impact on my career. And so thanks very much to Larry, also the award winner from 2013, if memory serves. Nick, of course, won in 2012. It's amazing how many SIGCOMM award winners have actually influenced my career, and you'll hear more about that. Well, Nick told you a good story about the most memorable talk I ever gave. I like to think it was my really significant contribution to SIGCOMM in 2003. And I think today's a very good day just to say, I'm definitely not bitter. And for all the people who don't understand the story, Nick told it pretty well, but just find an old person and they can explain it. So I want to talk about bridges. Now, if you've ever bought a networking book, hopefully one of ours, but even quite a few other networking books have a bridge on the front cover because it's a very good metaphor for networks. A bridge is a sort of a piece of architecture. Architecture plays a big role. I've been a fan of bridges for most of my life. I actually scared my father when I was quite young because he was an engineer, and I said I wanted to become an architect, which is almost the worst thing you could say. But in the end, I became a sort of engineer architect. But I do love bridges, and the one on the right there is from Edinburgh. It's the Fourth Rail Bridge, one of the most beautiful pieces of Victorian architecture. And of course, our company logo is a bridge roughly modelled on our first edition book cover. Our first edition, by the way, was also a very direct effort to look like Hennessy and Patterson's very successful book on computer architecture. So anyway, just before we published that first edition, I was in Stockholm for IETF, and I went for a run around Stockholm. And if you've ever been to Stockholm, it's made up of lots of islands connected by bridges. And so I had this insight, having just written a section on routing in the book, that when you're trying to get yourself back to your hotel after having gone a bit too far on your run, you first of all have to navigate to the next bridge by doing a sort of intra-domain route across the island. And then you go from island to island using something that's sort of like BGP to connect you from island to island. So I was pretty sold on the bridge metaphor in 1995, and that's how it ended up on the cover of our book. The other thing about this talk is I'm sort of a bridge myself. I have always had one foot in academia, sometime more than others, and one foot in industry. And I'll tell you more about that. But so this talk is kind of about bridging between communities, and it's also about bridging between technologies. Not so much about layer 2 bridging, but more like connecting together two ideas. MPLS, for example, connected ATM and IP. A lot of my career, and I think for many of you this will be true, the way to be successful in any area is find two areas where you're half knowledgeable and then become more knowledgeable than anybody else in how to connect those two. And that's been a lot of my career. Nick actually gave most of my talk in advance, by the way, so I'll go through this quite quickly. But I am quite a serious runner, even at this advanced age. There are competitions for old people, and I go and take part in them. This is one from a few years ago in San Francisco. It's actually a national championship cross-country race for old people. So the thing about runners is we love to measure things. Running is you can always say, well, who was the fastest person over 100 meters? You measure the distance, you measure the time. That's what running's all about. But we love to measure inputs. So for example, we'll measure things like how many miles per week do you run? It's a very, very crude but easy to grasp measure of how much running you do. So people use that to sort of benchmark how hard are they training. At my peak, I would do 100 kilometers a week, which is considered kind of a bit lightweight for a marathon runner, but it was just enough to get me under 3 hours. So you might talk to other runners about your weekly mileage, or if you've got a modern smartwatch, you might ask what your VO2 max is. I've certainly got one friend who's optimizing his VO2 max, and it's actually the only metric he cares about. But in fact, none of these things actually tell you anything useful, because at the end of the day, you've got to go run the race. And it's who crosses the line that actually matters. And that's just this multi-dimensional space of all these different things, some of which are immeasurable. And it's that impact comes from all these different things that you can measure. And today's talk is very much going to be about impact and how hard it is to measure, but also about the fact that there's a lot of different ways to have impact. there's a good way to measure impact, or it's not a good way, but there's an easy way to measure impact. It's called the H index. It's how many papers have you published that have been cited by at least H people. If you look at the SIGCOMM Award winners over the last half dozen years, there's a nice normal distribution of H index, and it's kind of clustered with a mean of about 100. So an H index of 100 is roughly what you need to be a SIGCOMM Award winner. But of course, like any good normal distribution, there's people who are somewhere off the mean. So congratulations to Deborah Estrin, who won this award a few years ago and is 2 standard deviations above the mean with her very large H index. Well, if there's one person who's above the mean by 2 standard deviations, there has to be someone below the mean by the same amount, and you can probably guess who that person is. So there is a strong possibility that the committee's made a terrible mistake, and I'll just let you be the judge of that. Now, let's talk about how I got to have whatever impact I've actually had. In 1988, I went to Edinburgh, and in a perhaps ill-advised move, I've kept a copy of my student identity card from 1988. As you can see, I haven't changed a whole lot. So the reason I went to Edinburgh was because in 1985, I was very, very interested in artificial intelligence, because it was pretty obvious to anybody who was a budding computer scientist in 1985 that AI was the next big thing. We were very convinced that it was just about to take off. So, of course, I went to the world-leading Department of Artificial Intelligence, or so I thought. But it actually turned out there were 2 very distinct departments in Edinburgh. There was the computer science department of serious computer scientists, and the AI department of people who were totally focused on replicating the capabilities of humans using computers. And these departments, it turned out, absolutely hated each other, with the traditional sort of rule that the fights are so bitter because the stakes are so low. So, as it happened, luck would have it, I actually enrolled in computer science, and my advisor was very quick to point out that I would probably do better sticking with computer science. And it was very fortuitous, because AI, of course, the bubble burst in about 1990, maybe even a bit sooner. And so I sort of dodged a bullet by not getting into AI. And I'll be coming back to the possibility that there may be a similar bubble going on as we sit here today. My supervisor was supervised by Robin Milner. So I'm the academic grandson of Robin Milner, which is certainly one of my claims to fame, I think. Robin is a Turing Award winner, sadly deceased now, but he was one of the kindest people I've ever interacted with. I didn't have a lot of interaction with him, but I would occasionally bump into him around the corridor in Edinburgh. And he stopped me in the corridor when I was getting to the early stages of writing up my dissertation. And he said, "Well, Bruce, how's it going?" And I said, "Well, you know, it's a lot of words, but I'm starting to enjoy writing, and I'm told that it's a good idea to aim for about 180 pages for a thesis in this era in the UK system." And so and I thought, well, what I'll do is I'll just write a lot, and then it's probably easier to cut it down at the end than it is to pad it out if it were too short. And Robin said, "Well, it would be even easier if you just wrote the correct length the first time." Which I guess it also applies to writing software. So that was just one of the very nice interactions I had with Robin Milner. And one observation I'll make is that that little interaction is still in my head today. And that's the sort of thing that we can do as computer scientists in our field, actually as humans. Anytime you have a chance to have an interaction with somebody, you have no idea how positive it could be for them if you just take the moment to be a little bit kind. So I love the fact that Nick picked up that about me. I wouldn't call myself a kind person, but I try not to suck. Anyway, in Edinburgh, I learned it was a theory school, and it was something I learned about myself was I really don't like theory, and so I did a sort of semi-theoretical thesis. Here it is. It's never really been opened, as far as I know. You can probably find it in the Edinburgh Library collecting dust, but that was my last effort at theory. I think also it was 220 pages. I sort of took Robin's advice to write, the correct length, except I overshot and then said, well, I'll just leave it there. So maybe I sort of bluffed my way through the whole dissertation by just making something that was too long for anyone to read. But I did learn about myself. By this age, I was happy when I was writing. And I'd started to spend a lot of time reading proper English literature, which I really didn't enjoy when I was younger. Actually, Scottish literature even more. Was a great thing for me. We didn't have the internet at home in those days, the dark ages as it was. And so I would read books at night, and it was a great thing to learn what it means to write a good sentence. And some people would say I probably learned a little bit too much from Henry James, who's famous for very, very long sentences and massive paragraphs. We get some critiques like that of our textbook. But the other thing was I actually wrote probably more software than most Edinburgh graduates because I liked building stuff. And so I learned how to program in standard ML. Any standard ML fans out in the audience? Thanks to those 2 to 3 people. I guess Jane Street today, of course, is very big on OCaml, which is the sort of descendant of standard ML. So if anyone from Jane Street needs some help, I'm happy to have a chat. So after I graduated, it was pretty clear to me I did not want to stay in the theory world. And so I was very fortunate to make a connection to Bellcore, a research lab spun out from Bell Labs. And I landed there in 1988. So I'll walk around a bit. This one works too. Beautiful. So this is another sort of bridging story. I landed at Bellcore in 1988, and this was a fairly risky move because I knew nothing about networking, but I had decided to go and work for a research lab that specialized in networking. And I think I, again, bluffed my way through the interview process by talking about something they didn't understand, which was my thesis. And they apparently believed I was smart enough to come and learn networking on the job. And they took the gamble, and I took the gamble, and it all worked out pretty well. But I landed in this spot where I had to bridge between the world of the telephone company, which owned Bellcore, and the world of the internet, which was what my group was starting to do research on. It was 1988. We were doing packet switching. We were building hardware to do very fast packet switching for the era. As Nick said, I built what could have been the world's first gigabit smart NIC. And that's what we needed to build a gigabit network, which was insanely fast at that point in time. So I had to sort of straddle between the world of the internet and the world of the phone company. And so I started to become very interested in the interaction between ATM and IP. So I started bridging those two technologies together. And a person who really, really helped me with this is the person who won the second SIGCOMM award, David Clark from MIT. One thing that was amazing about being at Bellcore was I had a great boss, and he was able to build a collaborative relationship with both MIT and the University of Pennsylvania. So we had this three-way collaboration, and that enabled us to start working on this very wide area gigabit network. I learned so much from David Clark. I think he was the one who got me to understand, contrary to what this article would have you believe, and what a lot of people believed, it wasn't ATM versus IP, it was how do ATM and IP work together. And that became my focus. And David advised me on things like how to architect a system like a smart NIC. And he was also an inspirational speaker, still is an inspirational speaker, sadly not here today, but I chatted with him before coming over. Seeing David give 2 talks at SIGCOMM' 1990, one thing I said to myself is, I want to learn to talk like him. I want to be as good a communicator as David Clark, and it became a passion for me to communicate as well as him. Now, David also introduced me to Larry Peterson, so he has a lot to answer for. That whole textbook thing, if you don't like our textbook, well, you can blame David Clark. So after 7 years at Bellcore, I made the jump from research to industry. Again, a bit of a risky move. I think I've only taken about 3 gambles in my life, and this was the second, jumping from a real research lab to a real product organization. As you can see, the bridge metaphor keeps going here. Cisco is actually named after the San Francisco Bridge. The logo comes from the Golden Gate Bridge. Just before, the logo that you see on the right there is Cisco's logo circa 1998, but the earlier logo had the C in lowercase, and that's how you could tell the old school Cisco people. They wrote Cisco with lowercase. But that was the old bridge metaphor. It's changed again, so the old bridge logo changed again. But I did not go to work for Cisco in California. I went to work for Cisco in Boston. And the reason I went there was because they had an ATM business unit. and they wanted to build this bridge between ATM and IP. So at this point, I had just finished my first edition book with Larry, and I thought, yeah, well, I'm now probably the world expert in how to connect ATM and IP, so, Cisco will be very happy to have me, and as it turned out, they were. And so shortly after joining Cisco, I went to the California office, and I was told to introduce myself to Tony Lee. Tony Lee had been at Cisco for a long time. He's, as you may know, the co-author of the BGP spec. Very, very legendary software developer and architect. So I walked up to Tony Lee, and I'd seen him around at IETF meetings, and I thought, well, I've written a book on networking. He will know who I am. So I walked up to his cube and said, "Hi, Tony, I'm Bruce Davie," and I got this totally blank look. He's like, "I have no idea who you are." And I was like, "Oh, well, I guess maybe I'm not quite so famous as I thought." But I think it's actually, again, it's a good story to be not so confident of yourself. Just be humble, go out there. And the good thing was, Tony did not think I was an idiot for having come up to introduce myself. He just didn't know who I was. And he took me under his wing, really. And between working with him and Yakov, that's kind of how MPLS got started. So I wrote a book on MPLS with Yakov, which was an absolutely brilliant career move. Most people would have said Yakov was the inventor of MPLS. He wrote a 2-page paper in 1996 that laid out the basic idea of MPLS, including connecting labels to prefixes and using more than one label on a packet. But my goodness, there was a lot of work from what Yakov wrote in his 2-page paper to building the actual MPLS architecture. And so I put the packet header here just so you feel comfortable that it's a networking talk. But most people, networking people, I should say, people at the IETF have a bit of a tendency to obsess about packet headers. People think MPLS was just a different way of encapsulating a packet, but it's way more than that. It's a really good piece of computer science. This is kind of a joke in computer science. Anytime you want to solve a problem, you just introduce another layer of indirection. That is what we did. We said, you can map a label to a thing and then use that thing to figure out how to forward the packet. So instead of an IP packet where the address says forward the packet to this destination, with MPLS you look at the label and you say, well, what does this label mean? Does it mean a prefix? Does it mean a traffic engineering path? Does it mean a VPN route? Could be any of those things. So you look it up, that's your first level of indirection. Then you do the second lookup and you forward the packet. Because it's also kind of late binding, right? You don't necessarily know what the labels are until you decide to start allocating them to different things. I just want to also give a shout out to Eric Rosen, who was the author of EGP. Now, EGP predates BGP. It was the original interdomain routing. And Eric was a brilliant architect. And he said, well, if we're going to do 2 labels on a packet, maybe we should generalize. So let's just say 1, 2, many. And so instead of just putting a 2-label packet header, we did a label stack. So you could push labels on, pop labels off. That was Eric's idea. Unbelievable how powerful that was. We ended up with 5 labels in some situations. So, that's just good computer science and just kind of tells you what a big team of brilliant people it took. And this is when I realized the risk that I took in going from academia to industry. Thought I was giving up on working with the best people. But I just worked with a different group of the best people. And they were really, really good at solving problems, getting pragmatic solutions, but doing things like generalizing. So I'll just explain MPLS really quickly for all those people who put their hand up saying they don't really understand it. I actually think Nick doesn't understand it as well as he thinks. So we used to think that by putting on this very simple label, we could make cheap, fast routers. We even did a high-level design to test that idea. The problem we discovered is that the packet lookup is not the hard part. Yes, you've got to do it, but you've also got to take the packet from the optics to electronics. You've got to store it somewhere while you're waiting for it to get to its correct output. You've got to switch it from input to output. All of those things at multiple gigabits are complicated and expensive. The lookup engine, even if you could drive that cost to 0, it's never going to dominate the cost of the router. And even if you could make it infinitely fast, you've got to make the other parts infinitely fast. So in the end, we never built a router that could only do MPLS. We only built routers that could do MPLS and IP. But fortunately, because of late binding, we could come up with ideas over the years and decades that followed of what to do with those labels. And the two really big ideas that really took off, the first one was traffic engineering. There was a lot of people actually using frame relay in the core of the internet to do traffic engineering. How many people here have heard of frame relay? Oh, that's quite a large number, because it was this kind of under-the-radar technology, much less sexy than ATM, but it was really being used in the core of the internet to do traffic engineering. So this picture on the left is the fish picture, and you can see why. And it shows you a particular scenario where it's difficult to do traffic engineering with just IP, but MPLS gives you a really easy way to control the path of traffic as it flows through the network. Picture on the right is a very simple version of an MPLS VPN. And this was an amazing innovation. This is why MPLS actually took off. VPNs were a massive business for AT&T and a number of other big service providers, but they sold the service to enterprises. It wasn't a service that people in the academic community paid much attention to. It wasn't encrypted tunnels. It was circuits, virtual circuits, using frame relay, connecting routers at the customer premises. AT&T literally came to us and said, we cannot keep up with the demand for this service, but we think maybe tag switching or MPLS could be a good alternative. You guys figure out the details. Well, again, it was mostly Eric Rosen and Yakov Rector who cooked up a massive architecture document that built the idea of VPNs. And that VPN technology was adopted by almost every service provider. And it displaced frame relay, and it made the service providers able to make money from their enterprise customers so they could build out the internet. So you can argue whether or not we helped the internet. We certainly helped the people who were building it. So what did I learn from all of this? Well, for one thing, it was really great to be working for Cisco in the 1990s. It was the days when the dot-com bubble was being inflated. We were beneficiaries of that. First of all, pets.com was making a lot of money by shipping, pet supplies to people's houses and losing money on every transaction, but making it up in volume. And we were building the internet to enable those web companies to get established. But in the end, selling routers was a very good business to be in the 1990s. It became a rather less good business in 2001 when most of our customers went bust because they didn't have a business model. And all of our routers that we had sold in the 90s came back on the used market. So we went through a pretty big deflation of the bubble in 2001. But so in the 90s, we had a lot of runway. We could just do what we wanted, have a big team to build this product that we didn't even know if it would make money. It did, but we didn't know that when we allocated headcount to it. Post-bubble, that got a lot harder. It was a multi-year effort. I would say minimum 5 years from the first paper to the first customer deployment. The customer input was critical. You have to have a multifunctional team so that you can have people who know how to listen to a customer and know when to not listen to a customer, and how to take the customer input and turn it into terms that engineers and architects can understand to build a product. And also, I think I've already explained, there was a lot more to MPLS than just how you put the packets on the wire. It was a big architectural effort. It was a real systems approach. And as I said, it was an enterprise thing. As Nick already told you, this technology, not really embraced by this community. As I said, I'm really not bitter about that, but it is just something that happened. We focused on it. Cisco made money from it. It was not a focus of this community. Now, I had some great mentors while I was at Cisco. And one of them pulled me aside one day and said, you need to scale yourself. To scale yourself, the only thing you can do as a senior individual contributor is try to make more people understand what you understand. So that means you've got to be mentoring people. That's how you increase your impact. One Bruce is all well and good, and we don't really want more Bruces, but we want more people who have some of the skills that you have. And so you need to scale yourself by mentoring. And that was just a really good piece of advice that I've always passed on to people. Anybody who's trying to become more senior in their organization, I say, yeah, don't just focus on being a good implementer or a good architect. Focus on how you scale your impact out through other people. Now, I also had a really nice discussion with two of my bosses in about 2006 who said, you know, Bruce, one day you're probably going to want to leave Cisco. Have you ever thought what you would do after Cisco? And I thought, well, this is a good boss, right? He's thinking about what do you do when you no longer work for me? And these bosses kind of encouraged me to think about whether I would want to ever take an academic job. And I said, well, actually, I did apply for academic jobs before coming to Cisco, but nobody wanted me. So I'm not quite sure I know how to get an academic job. And they said, oh, Bruce, I'm sure somebody would be happy to have you. So I went and talked to David Clark, and David Clark then passed me on to Harry Balakrishnan, another SIGCOMM Award winner, although not yet at that point in his career. And Hari ran the networking educational program for MIT, and Hari said, yeah, Bruce, I think we can find a way to create a class. In fact, you create the class, I'll get you all the resources you need to teach the class. So I taught a class in 2007 on advanced service provider networking, and then in 2008 and 2009, I co-taught with Hari Balakrishnan and Dina Katabi the graduate networking class. Now, those two people would both go on to become SIGCOMM Award winners, much younger than me when they did, but that's probably the best hit rate of any networking class, I would think, to get 3 award winners out of one class. And they taught me so much. They are incredible educators, incredibly kind people, and obviously super smart, but just very, very passionate about teaching. And so I used to be quite anxious going in to teach MIT students because, what if they knew more than me? What if they asked a question and I couldn't answer it? So I used to study like I was going into an exam the day before giving a lecture. But I learned so much from that experience. So that's kind of, again, the impact of mentors on my life. And I got to work in that really cool piece of architecture too. That's the Frank Gehry building. Legendary stories about that, but I won't dwell on them. Let's just say there was a lawsuit, but it's all worked out okay. Now, 2012, I got very keen on cycling while I was at MIT. So I joined the MIT Cycling Club. And you can see on the left there, I also moved to California in 2012 to join Nicira, the SDN startup that Nick founded along with Scott Schenker and Martin Casado. So I moved to California partly because the cycling looked really nice. And I took my MIT cycling gear, and that's me at the top of Mount Hamilton down near San Jose. Beautiful pre-work morning ride, middle of 2012. A couple of weeks later, I was riding my bike down Page Mill Road. This is the tough part of the talk, by the way. So I was riding down Page Mill Road, and if you know Page Mill Road, it starts very high up and it descends Twisty Road all the way down into Palo Alto. And unfortunately for me, I was coming down and a car coming up the other way crossed over the double yellow. So we had an impact at a relative speed of about 60 miles an hour. I broke 13 bones between here and here. So the picture of me on the right is me shortly after I got out of hospital and had been somewhat patched up, but still had the neck collar on and wasn't allowed to move my arm for a couple of months. But in the background of that photo, you can see some flowers and a balloon. Those are from Nick and his team. And I got so much support from people in the community who had welcomed me to California. Nick and Scott and Martin had sort of manipulated me to go to California, and I was very happy to have made the move. And they all just rallied around. Martin came over and installed a special shower head for me. Scott came over and sat with my wife when I was getting out of hand. And that's the kind of the point of the story, actually, is there was a mental impact as well. And we don't often talk about mental health in this community. I guess Australians just don't talk about it at all. But a big accident like that, it takes an impact. And so, the first thing I want to say is it's kind of normal to have mental health issues when you've been hit by a car, I think. But it's probably normal to have them for all kinds of reasons. And the best thing was I got all the help I needed. But I had about a 4 or 5 week period where I was a little bit like John Nash from A Beautiful Mind. How many people have seen that movie? Yeah, so I was neither as brilliant as John Nash, but nor was I quite as unhinged as John Nash, but I was pretty messed up. And I was a massive pain in the ass to be around. Nick didn't say this in his introduction, but he's seen me at my worst. But people came around to help me, and I didn't sleep for about 4 weeks. But I got very, very creative. And so during one of my sleepless nights, I had this very creative idea about our book. And I called up Larry and said, have you ever thought that our book might have a bigger impact if people didn't have to pay for it? Now, this book's published by Elsevier. They're a money-making organization. And so Larry and I talked through the idea, and we thought, we don't actually care about revenue. We care about who reads it. So for us, it's a massive win if we can make this book freely available. And then the question is, how do we sell it to Elsevier? So we did a conference call with our editor and her boss. And I was still pretty wound up at the time, so I think my wife was sitting there with me just going like, slow down, slow down. So I slowed down and we made this pitch to Elsevier. And the thing I remember was that one of them said, well, the Oxford University Press loses money every time they sell a copy of the Oxford English Dictionary because it's so big and expensive to make. But it's a great brand ambassador for Oxford. So I said, well, I'm happy to be the Oxford University Press or the Oxford English Dictionary for Elsevier. And so that's how we sold it. And so they said, okay, we will keep on selling your book. You can still buy it today as a printed thing on dead trees, but we will also let you publish it freely online. And part of the way we sold it was by threatening not to do another edition. But we also sold it by saying the book will be better because we are open source people. And we know how open source works. Trust us, open source is better than closed. So we're going to run this as an open source project. And so you can find the book on the internet today. There's a web page, book.systemsapproach.org. You can read the whole thing for free, but you can also go on GitHub and make improvements by raising issues and pull requests. Of course, it also means we can track how well read is the book. We don't have to worry about who adopts it for their class or how many copies got sold. We look at, did anybody read it? Did they look at a particular page more often? And so we actually get better feedback on how it's being used than we did when we were selling printed dead trees. So as I say, you can go to our GitHub repository and find not only that book, but all the other books that we're working on. We're up to 6 now. The security book is in the works. So please do come and have a look. Our books could be better. You can make them better. So, raise an issue, make a contribution. Okay, better check the time here. Oh yeah, tons of time. So SDN was the second big thing in my career after MPLS, or maybe the third after Gigabit NICs. So it was thanks to Scott Schenker's talk in 2011 that I got interested in SDN, and of course that's why I moved to California. So Nick gave this amazing talk at a conference in 2011. Sorry, Scott gave this amazing talk. I'm sure Nick gave an amazing talk too. But Scott gave the talk that really changed my mind about SDN. And he was basically saying we need better abstractions for networking, and SDN is the way to get there. And what I really took away from that talk was SDN was a set of ideas that had been around for a long time, but they were coming together, bridging together from the networking community and the distributed systems community to solve one of the classic problems of centralized control. How do you make centralized control scalable and not a single point of failure? And the answer is you leverage techniques from distributed systems that were getting developed in the 90s and 2000s. So it was the right time to bring an idea back. Now, meanwhile, at Cisco, people looked at this and said, well, we all know you can't have centralized control in packet networks. It's well known to not work. And they also said, the idea of separating the control plane from the data plane, it's been around so many times. It's never had an impact. Why would this time be any different? So very fortuitously, shortly after hearing Scott's talk on SDN, I went to the Cisco office in San Jose, and something happened that really irritated me. And I won't dwell on the details, but let's just say I walked out of a meeting with some of the best and brightest at Cisco thinking, You know, I'm not sure this is the A team that I joined almost 20 years ago. And so by the end of that trip to California, I was talking to Nick about his startup company. He introduced me to Martin Casado. And by the end of the year, I had an offer to go to Nicira. And that's how I got into SDN. So this was probably the third big risk of my life, to move from Boston to California, to go from a massive established company to a startup with, I think, under 100 people. I went in saying, well, I think the most likely outcome is the startup's going to fail, but I reckon I'll have fun. So I gave it a shot. Of course, I was wrong about the startup failing. And I realized SDN was going to be powerful because of the way Nicira was using it to solve real customer problems. SDN gives you a central API. A central API means you can use software to control networks. You can have automation of networks, things that we could never figure out how to do at Cisco because we would put an API on a box, but it was too hard to control a single box. You needed to control a network, and that's what SDN did. Network virtualization was, again, bringing together two worlds, the world of compute virtualization or server virtualization and the world of networking. And it was Martin who said, server virtualization changed the laws of physics for compute. You can snapshot a virtual machine. You can migrate it onto different hardware. You can roll it back in time. All of these things have been operationally transformative. It's what enabled cloud computing. But it also exposed a real problem with networking. The only thing I heard about virtualization while I was at Cisco was that people were talking about building massive layer 2 networks to deal with these migrating virtual machines. And part of me said, if the answer is massive L2 networks, you're asking the wrong question. So Nicira figured out how to crack this problem, and actually so did Microsoft with their VL2 project for a few years earlier. But we said, we're going to virtualize the entire stack from L2 to L7. And that enabled us to find the killer app. The killer app turned out to be microsegmentation. Microsegmentation meant you could build little isolated networks programmatically to create a little virtual network with very precise firewalling to describe exactly how a set of machines could talk to each other. And it got us out of the old, get it through the firewall and then let it rip, to a world where we had very precisely defined microsegments, and we jumped on the zero trust bandwagon, and we went from having about 6 customers who understand how to automate a network to having thousands of customers who understood how to get better security. So my takeaways from that experience were SDN was not the product. SDN was a technology that we used to solve a problem. Customer input was critical again, but it was also critical to ignore some of the outlier customers. We literally gave money back to one big and irritating customer because they wanted us to do something that would have soaked up so many engineering resources while not helping our other customers. So again, never underestimate the importance of good product management. And there were so many other technologies. It wasn't one thing. If you look inside, you can read the paper from NSDI. There are so many moving parts inside a network virtualization system. Zookeeper, the data log language, fast tunnels, everything was there. It wasn't just SDN. It was a big team, big set of technologies. That's what it takes to build a transformative product. And Martin was another great mentor for me. It's very embarrassing to get mentored by somebody who's like 20 years younger than you, but he's an absolute rock star. And you can see why I tried to dress like him as well. But he taught me in particular the importance of really good communication, and including the fact that you never stop trying to get better at it. And so I modeled myself on him. I worked super hard on every presentation, and you can judge for yourself whether I'm any good at it, but I have worked really hard to be a better communicator. Now, I'm just going to close with a few things that I think our community could do, because I hope you've realized this talk is about how we have impact. We can have impact through our technology. We can have impact through our mentoring. There's lots of ways to have impact. I want to talk about 3 ways this community might have an impact. I'm going to go from easy to hard. First up, social media, then AI, then the climate. So I don't want to disrespect anybody who's here who works for a social media company, but social media is largely a toxic hellscape. Thank you. However, there is one reason why social media goes the way it goes. It's because most of the social media networks are extremely centralized. So you can have a billionaire who does not have your best interests at heart decide how your social media works. Or you can use decentralized social media, which embraces the ideas that were embodied in the internet, 50, 60 years ago. The Fediverse is the word for decentralized social media. When I learned about having won this award, I didn't learn about it on social media because I'm not on most of them. I'm only on Mastodon. Well, I'm on one more, but I'll keep that quiet. But I went to the SIGCOMM' executive committee and said, what do you think about getting off the most toxic network and moving on to Mastodon? And so they said yes. So you can now follow SIGCOMM' on Mastodon at that handle. If that handle means nothing to you, just go read about Mastodon. It's pretty straightforward. You're all smart people. Okay, what about AI? I could have done a whole talk on AI. All that I want to ask from this community is please apply some reasonable skepticism. Don't believe everything that comes out of the mouths of people who have an axe to grind. So I wrote a newsletter article, you can find it at our website, about taking a middle ground for AI. And I cited this very nice paper from Princeton. It's about 50 pages. It's very, very well done, very well footnoted. And it explains how we can think about AI just like we think about the internet. Yes, it's an important technology, but it's not the same thing it's not going to change the universe the way some of the biggest boosters are making out that it will. It is a tool, and we have the ability to shape how it gets used. And you in particular have the chance to shape how your students or your peers use this tool. And I just encourage you to be a little bit skeptical and try to be a bit measured, because we didn't have a big impact on social media from this organization. We could have an impact on how AI gets used. And that plays into my third point, climate. We invented the technology that makes it easy for people to experience conferences like this without traveling. I didn't really expect to win this award, but I sort of thought, well, if I do, I certainly won't travel the entire, or halfway around the world to get there. But as soon as I won the award, of course, I was like, oh yeah, obviously I'm going. But yeah, my carbon footprint for 2025 is pretty bad. Now, many of you would have been at SIGCOMM' 2021 when we had it online. I think we can all agree it's a much better experience doing it in person. And we all would much rather do that. But I'm super excited to see all the people in Southeast Asia this week joining our conference remotely. And what a great idea that we've made the conference more inclusive and reduced our carbon footprint by using our own technology. So let's think about how we do more of that. And I also want to say, I kind of liked this paper that came out of a Dagstuhl seminar a couple of years ago, looking at the bigger problem of can we make the contribution of networking itself net zero? So I just want to make you think, we have an impact on the entire world with what we do, and climate, in my mind, is the defining issue of our generation. So let's think about how we're impacting that. And that includes every time you decide to use AI, rather than just looking up a reference, you're contributing to data center energy use. So it's a small thing, but let's be aware of it. Well, I'm just going to give you a few takeaways, and then we'll go to Q&A and then lunch. It's good to get out of your comfort zone. This is the one and only time that I appeared on live business news. It was a day when Donald Trump had announced a trade war with China. I was there representing VMware. My intention was to talk about technology. However, journalists don't really care what your intention is. So I was asked a number of questions about the trade war, and I was given some speaker tips before I went in, and I'd done a bit of media training. And all I can say is the trade war did not escalate as a result of what I said, and VMware's stock price was unchanged at the end of the day. So I thought that was a win. But I never got asked again to do that. But it was out of my comfort zone, and I guess all in all, I mostly enjoyed it. I've talked a lot today about how to make an impact. There are lots of different ways to make an impact. You could be the person who steers a giant container ship into a riverbank or a canal bank. Or you could be the little earth mover that chips away and chips away and chips away and tries to fix the problem. And everything you do, some of it will have a big impact, some of it will have a small impact, but you can always be thinking. For me, that's been the guiding principle of my career. It's why I went to Cisco, it's why I went to Nicira. It's because I wanted to make an impact. And it's why I open sourced the book. So you can always think about ways you can make an impact. It's not just necessarily about getting that SIGCOMM publication, not that I would want to discourage you from publishing in this excellent venue. And then finally, choose a good team. I don't win a lot of races, notwithstanding the fact that compared to some people, I'm decently fast. I'm not a race-winning kind of fast person. But I have won some relay races because you surround yourself with a good enough team, you can beat the other teams. That's the Lake Tahoe relay. We won the medal for old men by being the 8 fastest old men willing to do a lap of Lake Tahoe. So it was a good team. I was not the fastest, I was not quite the slowest, but it was a good team. And the same was true of every career decision I made, was join a good team and then try to bring more good people into your team. That's how you improve your impact. So I think that's it. I just want to say it's a tremendous honor to receive this award. I really did not expect to do it. And thank you all very much.
I'll orchestrate the Q&A and see how that goes as well.
Okay.
Yeah, perfect. Thank you so much, Bruce. I think this might be off.
Yeah. Can we get that mic? Can we have this mic going again?
No?
Yeah.
All right. Oh, there you go. Thank you, Bruce. Wonderful, wonderful talk. We've got a few minutes for some Q&A. Just raise your hand. It's a bit bright up there, so I can't promise to see you, but then someone's going to run up with a microphone, I think. So raise your hand if you have a question for Bruce. So while you're all plucking up the courage to raise... Oh, there's one up there. Okay. Raise your hand a little louder again. I just saw one. There you go.
That was a really great talk. My question is, did you ever try an Ironman?
Unfortunately, I missed the last word of your question.
Did you ever try doing an Ironman?
Well, it's a funny story. No, is the short answer. My wife is actually a pretty decent triathlete, and she's become a very good swimmer, but my swimming is really terrible. But I will say, I've done 7 marathons, and I've ridden my bike on a number of occasions for 200 kilometers. I've never got off my bike after 200 kilometers and said, you know what I need to make this day perfect? A marathon. So I would love to do a triathlon. But I think the Ironman might be a bit of a stretch too far.
Thanks for your talk. You mentioned you have 3 bets in your life, which make you very impactful. I'm wondering, how do you measure this bet is worth for you to take it, or just give it up?
Yeah, I mean, that's such a good question. So how do you know when it's worth taking a risk? I mean, there are entire books written about this, and it's a perennial topic of conversation between me and my friends. So I really think a lot of it comes down to, you know, when I decided, for example, to go to Cisco, The risk was I was leaving this very comfortable research environment to go to a product environment, and it felt a big risk. But I also felt the internet in 1995 doesn't feel that risky. I kind of think 1995, you could kind of tell the internet was going to be pretty important, and Cisco was the leading company. So I looked at Cisco, they offered a job, but what closed the deal was they said, we want you to be the bridge between industry and academia. And I said, not only is that a good company to work for, that is a company that recognizes my value. I'm not just another cog to go and write a whole lot of code, because you definitely don't want that. Not a lot of ML in the Cisco operating system. So they, they made a pitch to me which was compelling, and that's how I made the decision. Nicira was very similar. They made a very compelling pitch, and they sold the quality of their team, was what really sold me on Nicira.
Hi, Bruce. Thanks for the speech, and congratulations.
Thank you.
As somebody who has thought tremendously about educating, generation in networking, I'm up here, by the way, Bruce.
Yeah, thank you. I needed the hand. Yeah.
And I'm one of the older guys in the room, and probably one of the first of the generation that learned everything from your book and Larry's book. So thank you for that. But as we think about educating the next generation on the internet, how do you think we should help people think about the internet, in the sense that the internet in your book and the internet of the 90s was an artifact that was incredibly complex, but still one person could think about putting that in their head. And I'm not sure that's true today. And as we think about teaching computer networking to students today, I'm curious on your thought of what do you think are the right things? Is it really about layer 1, layer 2, layer 3? Is it about routing? Is it about social media? What should we be teaching this generation about networking?
Yeah, it's a tough question, and obviously we're actually working on the 7th edition now, so we'll be trying to get a good answer to that question. But so I think you're absolutely right. The internet is a lot more complex than it used to be. So leaving aside what you put into a book, I feel like the most important thing that I learned, and I think I remember David Clark saying something like this, is systems research requires teams. You cannot have one person who does it all. And so, to some extent, a big part of what we're trying to teach students is not layer 1 through 7. We've always been very anti-layerist in the way we teach. We are actually trying to teach a toolkit of systems approach reasoning. We try to teach people how to think about systems, how to manage complexity through things like abstraction. And so for me, that would be the best answer I could give is you don't teach them the way the internet is. You teach them the principles that will help them create the next version of whatever it is. And that is teaching things like, even in our first edition, we talked about principles, separating policy from mechanism, the end-to-end principle. All of those things are what you need to teach so that people can manage this massive complexity. The idea that you should be able to recite the 7 layers and tell me what happens in layer 6, completely irrelevant. So that's a kind of a hand-wavy answer, but I think, pull it back is teach them that it will be a complex world. They need to manage complexity, and that is about building abstractions and learning principles to manage complexity.
Hi, Bruce.
Please wave when you have the mic. There we go. No?
Here, let me.
Go for it.
There. Hey, thank you for that awesome talk. And my question is, this type of talk get viewed a lot by students, and you give a lot of very nice career advice. I was wondering if you could maybe target or give it a little bit for students in this area where AI appears everywhere, and people are like, why should I be taking the networking class where in my CV there needs to be AI, because all the jobs opening you need to make clear that you know how to handle AI. And then a lot of the people that takes networking also end up in whatever AI thing is gonna be the next thing. So if you could use some of your advice, maybe tailored to this audience of students that are at this moment where AI is so present around them.
Yeah, thanks very much. I do think that it's very hard to avoid the idea that if you're applying to a job and familiarity with AI coding tools is on the list of requirements, it's it's going to be very difficult to get that job without meeting those requirements. I would say that any company that makes those kind of requirements may not be the company you want to work for, but at some point that may become non-negotiable. I saw a really nice post from Sharon Goldberg from Boston University the other day, so I'll just paraphrase it. She's written a little policy for her students about how to use AI in class, and it's really about you need to learn a set of skills. If you can ask AI to help you find the reference that you need, but you can't ask it to answer the assignment for you. And if you do, we will know as your professors because we recognize AI slop. Now, I think it's going to get harder and harder to recognize AI slop, but setting a policy which is about motivating the students to do things that are in their best interest was, I thought, a very smart move. So that's my first sort of piece of advice is think about what is really in your interests. And, you know, it can be very difficult to say to students that they should be altruistic or that they should think about, you know, having a big impact beyond just landing a job out of school. But bear in mind, AI bubbles have burst many times in the past. So you should be thinking about what set of skills are going to get me through a 30-year career, not just what gets me through the next 2 years of job interviews. I could go on a lot more about the risks of AI and whether it's a good idea to do coding or use it to answer questions, but I would just say there's a lot of problems where AI does the wrong thing, and learning how to use it intelligently will be a skill. And so I can't say don't use it, but I can certainly say be very judicious in how you use it.
Okay, so I just want to finish with one last question from down here, Jim.
Hi, Bruce. So congratulations on the award, and thanks for a really fabulous talk. I wanted to follow up because I think talks like this are viewed by a lot of students in particular. So I have always thought you are a fabulous writer and a fabulous speaker, a fabulous communicator. What came across in your talk here is how hard you've worked on that, because I just sort of imagined, you know, you popped out of your mom and, you know, you knew how to write and you knew how to speak. And so maybe if you could reflect a little bit, A, on the importance of communication. I think you probably think it's really important. And B, what advice you would give to students about how to speak, how to write, how to learn how to do those kinds of communication.
Yeah, I'm so glad you asked that question. I'm just going to get some water before I answer it. Excuse me. So, first of all, don't mess your voice up. But so, you know, the title of the slide where I had me next to Martine Casado, I said, communication is trainable. So pretty soon after I saw that talk by David Clark in 1990, I signed up for a communication class at Cisco. And I can remember some of the things that I learned from that class in, let's say, the early 1990s. So for example, I used to and ah a lot when speaking. Now, I can't recall if I did or did not do that today, but he taught us this. If you don't want to and ah, break your sentences up. I'll deliver this part of my sentence to Ellen, and I'll deliver this part of my sentence to a person over here. And by doing that, I've calmed myself down, and I'm speaking slower. I also speak very fast, I'm sorry. But you can slow yourself down and avoid those and ah things. So that's a very simple, practical, teachable skill. You have to practice. I still mess it up, but practice, practice, practice. So it is very trainable. Now, Martine, as I said, it was a role model for me. We used to do these very high-pressure presentations at the big corporate events that VMware ran. And after we got our presentations, we would go out for a few drinks, and we always talked about the work we had put in to make our presentations look good on stage. And it's the classic metaphor about the duck going smoothly across the water, but underneath the legs are going flat out. So we do a lot of preparation, we rehearse, we get feedback, we practice, and then we try to get up on stage and not look like we're doing it for the first time. So a lot more I could say, but anytime somebody at VMware or Cisco would ask me for career advice, the first thing I would say is become a better communicator. Lots of people can write good quality code. Not many of those people can communicate really well. You want to be a good architect, you've got to communicate your vision to the rest of the team. You want your product to be successful, you've got to explain to a customer why it solves their problem, and you've got to do the communication in the other direction. You've got to hear why the customer needs you to do it differently and turn that into a communication to your team so they can build something that will satisfy the customer. So you will improve your impact if you improve your communication. And it's teachable, but it takes work, and hopefully it gets better with practice.
So let's congratulate and thank Bruce once again for a fabulous talk. Thank you, Bruce.